Hi guys, so I'm Sarah, data scientist at Data Scientist, and today we're making available a webinar on MLOps on GCP. Data Scientist is a company of bootcamp and continuous training in data science, data analysis, MLOps, data engineering, DevOps, and other data-related operations. We are happy to welcome you to this seminar, and if you want more information on the trainings, you can go to datascientist.com. So today we are with Tony Ruiz, Google Cloud Customer Engineer. He's specialized in AI and ML, and he's now going to present to you how to use Google Cloud's Vertex pipelines to simplify the ML development and deployment, and how to build an end-to-end MLOps workflow. Tony, you have the floor.
Hello, everyone. Yes, thank you very much for the introduction, Sarah. My name is Tony Ruiz, and I will be taking you through how to implement MLOps practices on the Google Cloud Platform. In front of you, we have an agenda. We have a very packed agenda. I'll be going through a brief overview on MLOps, introduce Vertex pipelines and what it means for the MLOps workflow. I'll also be taking you how to integrate this Vertex pipeline workflow with CI/CD, so you can implement a workflow with your Git repositories, right? And then we'll go into a final thought in QA. But a little bit about me. As I pointed out, I am a Google Cloud customer engineer based in Chicago. Customer engineers like myself have a technical background and work with different enterprises to establish solutions, to work through proof of concepts, and to solve business problems, right? So I have a very dynamic role, and one of the things I'm very passionate about is taking technology, taking the learnings that I've garnered through my different experiences, and sharing them with other people. Quick fun fact about me: I own a black cat. He's very naughty. He's back in the apartment right now, so he's not bugging me today. But just a quick little tidbit about myself, right? Before we dive into the presentation, I did want to call out some quick housekeeping notes. The first one is that opinions shared here are my own, right? I am not here as an official capacity of Google Cloud, right? So I'm not here as a spokesperson for Google Cloud. This is just me sharing my personal opinions, my personal experiences on the Google Cloud platform, right? This session that we have today also assumes that you have some foundational knowledge on machine learning concepts, such as training and deploying workflows, right? And it also assumes you have some foundational knowledge on CI/CD concepts, right? So you might be familiar already with how to actually check code into a Git repository, how to push it. What we want to go through is how do we stitch these two concepts together from the perspective of an MLOps workflow on Google Cloud, right? So I'll do a brief overview and walkthrough of these concepts, but yeah, without further ado, do we have any questions live before I dive in?
Hi, Tony. We don't have any question for now, so you have the floor again.
Awesome. Sounds good. So let's go through a quick MLOps overview. And what is it, right? So when you first start building a machine learning pipeline, you go through this intensive process of finding the right data set, the right methodology to build that pipeline. And at the end, you have a machine learning model. That workflow, that whole iterative process exists within this small central blue box that we see over here. It is just one part, one component of a bigger system, right? When it comes to putting that machine learning model into production, there's things that we have to take into consideration, such as how are we going to collect this data in the long term? How are we going to verify that our data processes are valid as we proceed and our model grows with time, right? How are we going to monitor things like training and data skew, right? And how are we going to serve our machine learning model as our use case grows, right? So this is the messy world of MLOps. And what it is that it's a culture and practice that aims to unify machine learning system development, the dev, and the machine learning system operations development, ops, right? So what happens today, or what are we seeing, and what are some challenges that a lot of teams are seeing today? You have two teams, usually the data science, and then you have IT. And you have this workflow where the data science teams get really close to the business stakeholders. They work on figuring out what data sets they need to train a model. They have, at the end of the day, a model. It's contained in some sort of model artifact or some model workflow. But guess what? It pretty much just stops right there. They take that model artifact and they throw it over the fence to IT. They drop it on their laps and they say, hey, you all figure out how to deploy this thing. IT people are not skilled in the considerations when it comes to machine learning and data science and statistical analysis, right? That's not their background. So there appears to be a great disconnect between these two teams, and MLOps aims to solve this disconnect. So let's start by a gentle introduction on how on some tools that we use to solve this disconnect. And the first one that we want to talk about are Vertex pipelines. So what are Vertex AI pipelines? It is a fully managed service that is built on top of Kubeflow pipelines. So I guess before we talk with Vertex about Vertex AI, we need to talk about Kubeflow. Kubeflow is an open source project that aims to simplify the deployment of machine learning workflows on Kubernetes, right? So Kubeflow can be deployed on your own local machine. It can be deployed on a Kubernetes cluster on any cloud on premise, right? And what Google Cloud did is create a fully managed service to be able to simplify the deployment of these workflows on Google Cloud, right? So what does this mean? What does fully managed services mean? It means that you don't have to worry about provisioning the underlying compute architecture that trains the model. What it cares about is your code, specifying the workflows, and streamlining the operations in order to execute a machine learning workflow. So as we stated, Vertex pipelines are fully managed. You don't have to worry about the underlying infrastructure. They're very cost effective and they do a lot of the things for you, right? They're secure by default. So they comes with a lot of different security features such as IAM, VPC-SC, CMAC, and it also does a lot of metadata tracking and lineage for you, right? So if you were doing this by yourself on Kubeflow, you would have to manage all these different aspects where a fully managed service takes care of that for you. So we are going to start by diving into some code pretty soon, but first we need to go over some high-level Vertex pipelines concepts, right? The first one is a component. And this is a self-contained set of code that performs one task in the ML workflow. The component runs in its own isolated container. And it also uses different specifications to specify inputs and outputs, right? So this is really critical to understand is that by isolating all these different components of our workflows, we create really reusable and scalable containerized instances that are able to do specific things. A task can be, for example, to fetch data from a repository such as a data warehouse. That component lives in its own isolated container, has its own specific packages, and you don't have to install those packages on all the containers that you have. You just isolate it within that one instance of a component. You take these components and you stitch them together, right? So now you have a modularized workflow that is built of different components and it offers different things like automation, orchestration, and of course, it also supports different workflows such as conditionals and loops. So one workflow that you might see in a machine learning pipeline is to deploy a machine learning model if it meets a specific criteria, such as an evaluation metric, right? So at a high level workflow, this is kind of what we're going to be looking at. We're going to take these components, build a pipeline. We're going to take that pipeline, compile it, and create a pipeline artifact. This pipeline artifact is essentially a YAML file. It can also be a JSON file. But what that pipeline artifact does is that it creates a particular set of instructions. It creates the recipe that is necessary to feed into the fully managed Vertex pipeline service in order to run the entirety of our workflow. Once again, Vertex AI Pipelines is fully managed. By creating that compilation, that finished artifact, all it's doing is executing that workflow then. And of course, as the workflow is being executed, we are able to track all the metadata through the service. So with this is just a couple examples on code and how you author those components, right? So it is a Python base um, functionality, right? So in this case, think about it in this way. You can specify a particular function that takes an input, has an output, and then use this component decorator to specify what those components look like. So these are very, very lightweight, and it makes it really easy to build very custom workflows using these the Vertex Pipelines SDK. So we're going to dive into this code in a little bit, but this is just a sample workflow of what a potential Google Cloud Vertex pipeline looks like. We have different types of components or things that we call operations. The first one that you see here is a data set operation to fetch data set. The second one over here is a training operation to execute a training job. As you see here, we're specifying where our inputs were. So in this case, we want to make sure that our data set comes from our previous step, and we're creating a machine learning model. And then we have a particular step here to deploy this workflow. All right. I know I have said a lot. It's time to see it being put to practice. But before I dive into my Vertex AI console, I really want to take a pause here and see if there's any questions that we can answer. What is a particular step to deploy the workflow you have just talked about? That's a great question. That's the very last step right now. It's the model deploy operation. You see here that we are specifying the model from our training job operation that was defined on top. We're defining a create endpoint operation, right? So we are specifying that we want the model deployed to this particular endpoint. And we're also specifying some resources such as the compute underlying that infrastructure. So you see here we have a scaling factor for the replica counts of that virtual machine that is powering that endpoint. And there was a second question that just popped up, but I didn't get a chance. What are the skills of an MLOps engineer? That's a great question, right? So the skills of an MLOps engineer requires familiarity with both machine learning concepts and taking the understanding of those machine learning workflows and understanding what is required from an infrastructure operations perspective on how to serve that model. So for example, in a traditional software engineering practice, you would just be focused on your code, right? You have a packaged container with code, you deploy it to a service. With machine learning workflows, we have to be also considerate of our data, right? How do we ingest data? How does it scale? How are we feeding this model? How are we retraining our machine learning models on that new data and monitoring those different components? So it's a different, more holistic approach to both machine learning and operations. Where do you put A/B testing concept in this schema? That's a great question. There is a specific component step that you can specify. It's not here in this particular example, but you can create like an evaluation step that uses evaluation data sets to be able to compare different models. It's not specified here, but it is something that is possible.
Hi, Tony. I think these are all the questions that have been asked for now.
Awesome. Excellent. So let's dive into our Google Cloud Console. For those of you who have never seen it, this is what it looks like, right? On the top left-hand corner, we have this hamburger menu, and over here we have a variety of services and products. We want to go into Vertex AI, and we see here that underneath the Vertex AI portfolio, we have a variety of different tools. We have our a model garden, for example, to find different machine learning models that are pre-curated for us. We have infrastructure for developing our workflows. So we have our Workbench here. And if you're into generative AI like I am, you also have a playground to be able to look at some of our generative AI features. For this use case, I have a Workbench already defined. A workbench is essentially an instantiated version of a Jupyter Lab notebook. If you're already familiar with that, Jupyter Lab is a great development environment for data scientists. We are going to be stepping through some code in this workbench instance. So I am in a development environment now, and I have a project set up. I have this particular experimentation notebook. This is just a quick notebook that aims to define how I'm stitching these products together and kind of just walking through what I'm doing, right? The first step is to make sure we have proper packages installed and we're defining our dependencies. The next step is to make sure that we are defining a couple different variables, such as our GCP project. A project is essentially a container space for all GCP, for different GCP resources, right? We're specifying some things such as the region where we're going to deploy our model, right? So cloud workflows get deployed to specific regions, specific data centers. In this case, we are in US Central 1 because I am in Chicago, right? And we're specifying a Google Cloud Storage bucket. Google Cloud Storage is essentially a repository for unstructured data sets, right? So our first step that we're defining here is a step to get data. And one thing that you're noticing here with our Python component decorator is I'm specifying a base image of Python. So you can use different Python versions and stitch them together if you needed to, because at the end of the day, these are isolated components that only care about the input and output of those components, right? I'm specifying specific packages to install. I have Pandas, scikit-learn, Google Cloud BigQuery, a couple others, right? But notice how I'm pinning the versions on these packages. And that's one thing to really take into consideration is that if you don't pin the versions on your packages, different updates happen and these can cause breaking changes in your code. So now these components are isolated. They have specific versions pinned to them. You can reuse them, right? And now I have a step to get data, right? I'm going to be loading a sample data set from Google BigQuery. Google BigQuery is our serverless, scalable, no ops data warehouse, right? And in here, I'm specifying a client to BigQuery. I'm specifying the actual query. In this case, our use case will aim to determine if a user will buy on visit. So essentially, we're building an XGBoost classification algorithm based on features such as bounds, such as time on site, et cetera, right? We are going to run that query job. We're going to use the scikit-learn package to create a train test split. And then we're going to save those train test splits to a particular location in Google Cloud Storage. So notice that we're saving the output to a dataset train path. And that dataset train path was defined in our function here. So we have a particular path on where our outputs are going to be stored. The nice thing about this is that now with this particular component, if I'm working on a broader team, we can reuse this component. I can abstract the query and pass it as a parameter for this particular use case. And now we have a a reusable component that you can specify specific query and reuse it across different machine learning workflows across different teams, right? Awesome. So after we get the data, what happens next? We have to train these machine learning model with the data that we have, right? We have to train a machine learning model. We have a new component defined. This time we're going to specify our XGBoost library. We're going to specify pandas and scikit-learn. We have our input here from our previous step, right? So we need the dataset path where our data lives. And the output of a machine learning training job will be our model artifact, right? When you train a machine learning model and you save it, it creates an artifact such as a .joblib artifact or .pickle artifact that you can save, that you can deploy to different areas. That's basically what gets, when a traditional data science workflow, that machine learning model artifact is what gets deployed over the fence to IT, and IT kind of just stares at it, doesn't know what to do with it, right? So we are simplifying that process, right? We're taking care of the fact that we're going to train and deploy a machine learning model to infrastructure. As you can see here, I'm not doing anything super complicated. The goal of this session is to show you how to stitch together these components to create a reusable workflow. And a typical machine learning pipeline, you would be doing a lot more, but I want to abstract away the complexities. I am going to be just specifying a model using the XGBoost classifier. I'm going to be fitting a machine learning model on the data set that we specified, creating an evaluation score, and then just saving it, right? Very simple, nothing fancy going on here. The next step that we have is an evaluation step, right? So we have a test data set that was already defined. We have our model artifact. We have a specific set of metrics that we want to capture and a bucket, a Google Cloud Storage bucket on where to store those metrics. So this step is a little bit more involved. We are loading the machine learning model from our previous step. Remember that on our previous step, we just trained a machine learning model and got back a model artifact. We are taking that model, loading it up, using our evaluation data set to create some scores and capturing those metrics, right? That's all we're doing in this evaluation step. And then the next step is to finally deploy that machine learning model, right? So we see here that we take our model, we take our endpoints that we're defining, and we are basically just taking that model artifact and deploying it to that endpoint. Finally, so what did we just do? We just specified each of those individual components. Now we are going to define a pipeline, right? Notice that we have this pipeline decorator here. This pipeline basically defines how those machine learning those components get stitched together, right? So we have our data set operation that we define, right? This is our call to BigQuery to fetch some data. We have a training operation to train a machine learning model. We have the evaluation operation that we just specified earlier. And this is a really cool concept within Vertex pipelines that you can specify conditional operators. So we want to check to make sure that our evaluation operation returns a deploy equals true. Let me step back over here and walk you through that. So notice that we have some decision logic here. We want to deploy true if our score reaches a specific score threshold. So we wanted to see that our model performs at a specific metric. And if that returns true, we are going to deploy our machine learning model to that endpoint. All right. Now, this is something that we have to keep in mind. I am giving an example of an end-to-end machine learning workflow. Depending on your use case, you might not want to deploy your model automatically. You might just want to create that model artifact and have that model artifact go through a more rigorous process where it gets deployed to different environments. It gets unit tested, it gets integration tested, like all these different tests that happen. Remember, we specified A/B testing, right? So all those things can happen at different areas of the process, right? For the purposes of just instructing on how to create an end-to-end machine learning workflow, I set it up in this fashion where we train a machine learning model and just deploy it as a unified workflow, a unified pipeline, right? If I run this compile step, notice here that I am creating a pipeline.yaml file. And this pipeline.yaml file is essentially the secret recipe that feeds the instructions to the Vertex AI pipeline service to be able to execute the machine learning workflow. Once again, I am not setting up VMs in the background. I'm not worried about security. I'm not worried about logging. I'm specifying that pipeline.yaml, that function that I want to execute. So that's a pipeline function that I have over here. And I am just saying, hey, Vertex AI pipelines, execute this workflow. And it's doing that all for me. So let's go through and check out what a pipeline workflow looks like. You see here that I have been messing around with it, and it's been quite some time since I've been back in this project, but I have my most recent runs over here that ran successfully. Now, this is a really cool concept with Vertex AI pipelines is this visualized graph to show you what is it that you did and what's being fed into what. So you have a get data step, and you have a reproducible model artifact, right? Now you know that this get data step creates a data set and I can track it. I know that it goes to this particular area in cloud storage bucket. I know that that data set is being fed into my training machine learning, this train model step. And from that, I have a model artifact. I have my actual machine learning model that is saved to cloud storage, right? So I know where things are being tracked. I know where things are being traced. I know that there's an evaluation step, and I'm able to track metrics on this evaluation step. In this case right here, we have a confusion metrics, we have an ROC curve. Our data set was highly imbalanced. So in a typical machine learning workflow, you would do some more data cleaning, some more data preparation. But this is just something to consider. Now, when I go back and iterate on this workflow, I can track that from previous runs, this machine learning model got better, it met some certain thresholds, and et cetera, et cetera. It passed the evaluation process that I have. So now the next step is to deploy. And you can see here that it deployed to a model endpoint, and I'm able to track that metadata. So all this you would have to do manually if you're doing it by yourself on an on-premise environment, on an on-premise Kubernetes workflow on your machine, right? You would have to track all the metadata, address security concerns, address logging. That pipeline.yaml file that I created did all this for me. I did not have to worry about provisioning all the underlying infrastructure that ran these steps, right? So this is the simplification of a machine learning workflow. So I have said quite a lot. I will go back to the presentation, pause, and ask if anyone has any questions. Yes, you can pre-process the scripts. I did not include it in this example just for simplification purposes, but yes, you can have a step that gets the data and include an additional step to do some feature enhancements, some feature engineering, and have a more complicated partitioning where you have training data sets or testing evaluation data sets. So those steps can be done, right? Just for simplification, I made it so the fetch data step and the pre-process step were all in just one process. How do you make these queries reusable? That's a great question. You can check them into a Git repository. There's different capabilities in BigQuery specifically to make those queries reusable, right? But essentially, you just treat those queries as code, right? What happens if you reach a specific score? That's a great question. In this case, if you don't reach a specific score, the model doesn't deploy. The machine learning pipeline would just say, hey, it failed. We did not execute all the components in our step because you specified an evaluation threshold. The model did not reach that threshold. We did not deploy. What kind of problems have you encountered? Industry examples. Wow, there are many. Where can we even start? Not monitoring your data properly is one issue, right? Like not understanding that your data can evolve with time. A perfect concrete example of that was during the pandemic. Let's say you had an e-commerce machine learning model that tracks sales or some forecasting model of some sort. You're expecting particular trends for the past 3 years, and then the pandemic happened, and all those trends kind of just went out the window. It was a new world. People were not going in the stores. People's buying patterns changed. We had to account for that. So understanding your data set is key. Understanding how it evolves, how it changes, it is key. I think that may have been all the questions. Or on what subjects have worked. I'm not sure how what you mean by that, or if you want to elaborate on that, but I'm
I
not
think the
super.
person meant on what subject have you worked so far?
Oh, like
With
use
prediction.
cases, industries, things of that nature, variety, right? Forecasting is one that I've worked with. I've worked with different models using recommendation systems. The one that been most heavily involved now is generative AI workflows. So it's not demonstrated here. This is a traditional machine learning workflow, but these different Python functions can be stitched together for a generative AI workflow as well. What tools does pipeline job use? Interesting. Let's go back. Share this tab instead. And tools, I'm assuming you mean like parameters are being passed in. I'm specifying this AI platform pipe on the job. I'm giving it a name. I'm specifying the template path. Remember, that's the pipeline.yaml that we have. And I'm specifying a pipeline route. That's just a location in my Google Cloud Storage environment where I'm storing all of this metadata for the pipeline workflow. Last question. Where do you store your run? That's exactly the metadata of that run is stored in that pipeline route option right there that you have in the bottom. So I can go into Google Cloud Storage and track all the metadata that was executed in that run. All right,
That is all for now. Thank you.
awesome. Let's move on to executing a CI/CD workflow, right? So some quick definitions. CI is the continuous integration of your code. If you're working in a development team, people may have their own separate branches. They're all checking their code into the same repository. You need some way to make sure that people are not stepping over each other's toes, that at the end of the day, this code runs, right? Continuous delivery is how you ship that finalized artifact. Typically, it's a machine learning. It's a image of some sort, right? That gets shipped to a container, right? And then continuous deployment. It's how you deploy that container through different environments. When I say environments, think about a development environment where you might be working on actually creating the container. You might have a testing environment where that container or that image ships to that environment where there's further tests run on it. And finally, production, right? It's also been called, it is a requirement that you have continuous delivery to have continuous deployment. And machine learning, right? That deployment also means the deployment of that model artifact to different environments and prediction services. So that is a new nuance to the word deployment, right? Because we're dealing with machine learning concepts now. And some other things that we need to take into consideration is continuous training. As we see new data, as some sort of event happens, we need a trigger that says, hey, my machine learning model is stale. It needs to be able to see some new data in order to keep a fresh and accurate machine learning model. So we need to account for continuous deployment of that machine learning model, but also continuous training of that machine learning model. What does that look like? So If you were a software engineer and all you cared about was delivering the code, this top portion, those top two boxes, code and CI/CD pipeline, is all you would care about. But because we're creating a machine learning ops workflow, we have to take into consideration data. So that bottom section is something now we have to also discuss. We need data. We need to be able to take the output of that CI/CD pipeline, create a continuous training workflow, and at the end of that workflow, once it passes the proper gates, once it passes the proper permissions, we deploy that machine learning model artifact to a prediction service. Right. So how do we do this on Google Cloud? We have a couple of new tools at our disposal. The first is Cloud Build. This is a fully managed CI/CD service. It will manage the connection to a repository such as GitHub. So in this case, I have a remote repository in GitHub. I have a integration between my GitHub repository and Cloud Build that says, hey, when some code gets checked into my repository, execute this build. The infrastructure that is executing the build exists in Google Cloud, right? And the steps that are specified in the build are defined in a cloudbuild.yaml file, right? And the output of this, once again, is not a machine learning model job. The output of this cloud build is an image that creates our pipeline.yaml file. It's the instructions to run the machine learning workflow, right? We're not actually running the machine learning workflow. We're creating an image to create the instructions for our workflow. I'll get into what that means in a second. I know that may be a little confusing at first, but bear with me. Notice that this cloud build YAML file specifies the instructions. I know it's a little hard to read, and I will zoom in a little bit when I go into the code, but we have specific steps to build an image, to update our latest image, to be able to take that image, put it in a container, execute our machine learning code, right? And then store that output, that pipeline.yaml artifact in a location. That is all that this cloud build.yaml file is doing. Now, depending on your use case, you might want to do various different other workflows, right? Once again, for simplicity's sake, I kept it as consistent, as concise as possible, just to be able to walk through it in the allotted time that I have. I mentioned containers and images, right? I'm not going to deep dive too deep into those concepts if you're not familiar, but a container is essentially an abstraction of some sort of compute that can run code. That code gets packaged in an image, and an image is essentially an artifact that defines all the dependencies, all the different code aspects, everything that is required to run that particular set of software. You take that artifact, you deploy it to you land it in artifact registry, and from there you can manage and store it securely, and you can deploy it in different environments. So you have an image defined, it's wrapped around a container. You can deploy that image to Google Cloud Kubernetes engine, for example, right? So let's define an end-to-end workflow for CI/CD, right? On the left-hand side, we have our local development environment. Within this development environment, we have that cloud build YAML file. I'm going to push code to a remote repository. Once that code gets pushed, it is going to trigger a workflow with Cloud Build. Cloud Build is going to look at the source files in my repository and say, what do I have here, right? It's going to execute that build process. Remember, our cloud build.yaml is what defines that build process. Excuse me. At the end of the day, we're going to have an image. That image is going to be pushed to artifact registry. And that artifact registry image, that image, all it's going to be doing is creating that pipeline.yaml artifact. Remember, this pipeline artifact is not actually the execution of our code. We need a scheduler to actually run that artifact, right? So what does that scheduler look like? You might have a continuous training workflow that requires you to train your machine learning model on a weekly basis. So that's could be set up through a cron job. It could be a monthly basis. It could be a daily basis, right? You might have a machine learning workflow that triggers to a particular event. Let's say you're not getting the predictions that you desire, the evaluation metric. If you're doing some real-time monitoring on your machine learning model, you might have a Kafka queue, for example, that pushes to the schedule, pushes a message to the scheduler and says, hey, retrain my machine learning model. My pipeline artifact has everything that it needs to go back and look at all the requirements, all the data I need to get, the machine learning model, the deployment, and at the end, it's going to be able to train a machine learning model and for our use case, deploy it to an environment. I know that was quite a lot. I will pause for now. And I am so sorry. I meant to go through my slides and I was not sharing my slides. So let's go through that real quick. So at this top section, once again, you have code, you have CI/CD. If you were a software engineer, this is all you would be caring about. At the very bottom, you have data, you have your continuous training pipeline, you have a prediction service. This is Cloud Build. As I specified, it's a fully managed CI/CD service. Cloudbuild.yaml. This specifies the steps for deployment. Artifact registry is where we store our artifacts. And this is the example workflow that we're going to be going through. Apologies, I thought I was sharing my slide. I was not. I was on my Google Cloud environment. But we will be going through these steps in full, just so we can come full circle. Before I get into that, I'll answer a few questions because I know I just talked a lot and I want to get some thoughts from the audience. Is it not the deal that data engineering, or is it the role of MLOps? That is a great question. I think MLOps people are also the data engineers, right? They have to also be data scientists. They also have to be machine learning engineers, right? ML ops engineer is a very loaded term and it can mean different things for different people. I think it's a unified team where you can have data engineers, you can have the statistical data scientists. So it depends, right? You might have some ML ops engineers that are more data engineering heavy, they're more operations heavy. So yeah, it kind of just depends on your team and what are you looking to build from a team perspective. How do you update the model in the deployed API when retrain? That's a great question. So that is done in our pipeline artifact. Remember that we have a scheduler, and that scheduler would execute that pipeline.yaml file. That pipeline YAML file specifies where that model gets deployed, right? So you have a scheduler that is constantly listening to a particular event or frequency to retrain that model. I think I just answered that question. All right. Without
Yes.
further ado, because I know that there's quite a lot of content to go through, I will showcase this tab over here. So let's go through this example. The first step that we need to do is take this notebook that I have here and write it in a pipeline.py file, in a regular text file. Why do I want to do that? And it's a reason why I call this notebook file experimentation, is because I am really just doing this from an experimentation perspective to see what code works, right? Notebooks allow me to iterate quickly, but I want to keep it on a text file.py level in order so I can do the code check-in process or make my life easier with my repository workflows, right? So I have a pipeline.py that I have written. I have a Docker file that specifies the specific instructions on how to build an image, right? So that's essentially why we use Docker. I'm adding that pipeline.py file. I have a very minimalistic requirements file, but that requirements file is independent of the requirements for each of my pipeline component steps. Those two things live as separate definitions, right? The only thing I care about from this requirements file is I want to make sure when I run this pipeline.py, all I get is this compilation, right? This xgb pipeline.yaml. That's my pipeline YAML file. That is a secret sauce that creates that machine learning workflow, right? Once again, this is not actually running the workflow. I'm creating the instructions to run that workflow. The next thing I want to step through is this cloud build.yaml. When I check in my code to a repository, I'm going to be building a Docker image using the latest image that I have. I am then going to be looking at the code and updating that model that Docker image, right? So I'm going to be taking my latest image, building a Docker image, and pushing out a new Docker image based on my repository changes. I'm going to take that new image and place it in a container and run the pipeline, the python.py file that I have, the pipeline.py file that I have, right? And I'm specifying a couple environment variables. Notice that these can be different environment variables. So if you have a more complicated workflow where you want this deployed to a dev test, you can specify that through this cloudbuild.yaml file. Once again, the output of this step is that XGB pipeline YAML file. This is the recipe that is going to run our machine learning model workflow. So I have a repository here. This is my Git repository. Once a new push happens, whoops, let's go over here. You can see here I was updated 1 hour ago with some new code. This triggered a machine learning build, and you can see here that I have a particular trigger named. This is listening on my actual GitHub repository, and I established that connection within Cloud Build here. So I link a repository to my GitHub repository. I have a trigger defined here. In this case, this is just the name of my repository, and I just put trigger in front. And it's listening on a particular event. So in this case, if I push to a new branch, if it's this repository, and I don't care what branch it is, once again, this can be set up in various different ways depending on your use case. And when that new change occurs, I create a new build. What is in this build? It is all the steps that were defined in this pipeline.yaml file and the cloud build.yaml file, excuse me. So we build a Docker image. We take that latest Docker image and push it to artifact registry. We take that latest Docker image and create that pipeline.yaml file. We run the pipeline.py, and then we store that pipeline.yaml file in Google Cloud Storage, right? So what is the output of that? I'll share this tab. This is our Google Cloud Storage environment. We have now this XGB pipeline YAML file that was just dropped from my most recent push. I'm going to go in here and just download, look at the metadata. Let me see if I can share this. I cannot share this. Let me see if I can, 1 second. Okay, I can't share the actual output, but just understand that it kind of looks already like this over here. I'm not sure where. Presenting, share screen. Excuse me. So you see here that we have our XGB pipeline.yaml file. What does that actually look like? It looks something similar to the effect of this, right? Once again, this is just the instructions on how to take that, our machine learning workflow, right? We now have defined a scheduler, and this exists right now as a notebook, but this, once again, is a fully managed service. I am specifying where that pipeline YAML file lives. And all I'm doing is creating a schedule in this case. I want my machine learning model to run weekly at this particular time, but there's other different events that I can specify to retrigger that workflow, right? So I have my pipeline.yaml file stored somewhere, and I have this particular schedule defined to take that pipeline.yaml file and run it at a particular interval. So now if I want to train a machine learning model weekly, I can do that. Every time I check in my code, you create a new image. That image has new changes, and you're creating a new set of instructions to be fed into a fully managed service, right? So within the time span of an hour, I took you through a very minimalistic, a very simplified machine learning workflow that can be deployed on Google Cloud. I will pause there and get some questions from the audience. It's an interesting question. So you can update the model without changing the container because the container is just holding the execution steps for the workflow, but your model is going to be changing, can be changing independent of the code, right? Your model will change with new data that it sees. So that's how you're updating the machine learning model. In case that is streaming predictions, for example, if it's a streaming prediction pipeline, it still just would be deployed to a particular prediction service, right? So that's kind of independent of this workflow. Although this particular use case was batch, right? Maybe we need to update and tweak some things if it was a streaming use case.
Okay, Tony, that is all for now. Thank you very much.
Awesome. So let's share this tab. Well, with that being said, that is the end of my presentation. I believe we can just cut to some feedback or maybe get some thoughts from the audience, but that is all I had to present on.
All right. Thank you very much for your presentation, Tony. I think we'll wrap it there because we have asked all the questions that the audience asked so far. Thank you very much for your presentation. And I will just remind the audience that Data Scientist is a company that does training, bootcamp, and continuous training in data science, in MLOps, in data engineering as well. And we will be listening to you, and you can contact us through the website datascientist.com. Again, thank you very much, Tony, and have all a good day.
Thank you very much. You too, sir. Bye, everyone.